Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now.
Welcome back to Quark Talk, where we explore the depths of the universe and the marvels of science, amongst other stuff.
Today's episode delves into a cosmic phenomenon that has captivated physicists and boggled the brightest minds at the Institute for Advanced Study.
Yup.
It's the OMG particle, or as some people like to call it, the Oh My God particle. This was actually suggested to us by one of our listeners, and it seemed quite interesting, so we decided to make an episode on this.
Yeah. So the history of the OMG particle is basically it was directed in the early 1990s by the Fly's Eye cosmic ray detector, and it had an energy of 3 into 10 to the power of 20 electron volts. That's like 50 joules within one small particle that's the size of a nucleus.
Ooh,
Now imagine trillions and trillions of them together.
that's too much energy, bhai.
Yeah, that's like enough to do anything. It's unimaginable.
To put that into perspective,
TOK?
yeah, TOK. Even the most powerful particle accelerators on Earth, such as the Large Hadron Collider or LHC, which is at Switzerland, they can accelerate protons to energies of about 10 to the power 13 electron volts.
Bas 13 sirf.
हाँ, उतना ही. This means that the OMG particle had more than 10 million times the energy of the particles produced by the LHC.
Oof.
Imagine a single particle with the energy equivalent to a baseball traveling at 60 miles per hour. Yet this particle was moving with energies which were far beyond our current experimental capabilities.
Yeah, exactly. The thing is that cosmic rays are high energy particles that constantly bombard us from outer space, and they come from a lot of places like our own solar system, distant galaxies, and the intergalactic medium. Most of them that we encountered are of relatively low energy as compared to the OMG particle. That's why it was so unusual, this discovery of the OMG particle.
Correction, groundbreaking discovery.
Yup.
Yeah. The interesting part is that the particle's detection challenged existing theories about cosmic ray acceleration. Before this discovery, scientists believed that cosmic rays could only achieve certain energy levels before their interaction with cosmic microwave background radiations, which is basically a byproduct of the Big Bang, and this would prevent them from retaining such high energies.
Oh yeah, that's like the GZK cutoff or the Griesen-Zatsepin-Kuzmin cutoff.
God, these people and their names now. It's so confusing, even more than the theories themselves.
Literally. So, according to this model, the ultra high energy cosmic rays should lose energy through interactions with the cosmic microwave background, right?
Yeah, correct.
So, the GZK cutoff essentially sets that limit to the maximum energy that they can have while traversing across the universe.
However, the OMG particle defied this prediction.
Oof.
Its energy surpassed the GZK cutoff by a sufficient margin, which caused scientists to reconsider their understanding of cosmic ray acceleration. This also meant that we got new methods of research to explain how such high energy particles could be produced and they could travel across vast distances in space.
So, several hypotheses have been proposed to explain the origin of the OMG particle. And one leading theory says that these cosmic rays that are ultra high energy were generated by supernovae. And supernovae are basically cataclysmic explosions that occur when massive stars exhaust their nuclear fuel and they undergo gravitational collapse. Basically, they go boom.
Haha.
And these explosions create shock waves and they can accelerate particles to extremely, extremely high speeds.
Another source of these particles is gamma ray bursts. Gamma ray bursts are among the most energetic and explosive events in the universe.
Oh, Hulk.
Yeah, Hulk. These
Bursts.
bursts, like Hulk outbursts of rage, they occur when massive stars either explode in a supernova or when neutron stars merge. The intense conditions during these events could actually accelerate particles to energies observed in the OMG particle.
Yeah, active galactic nuclei are also considered as like possible sources because they are regions surrounding supermassive black holes and these black holes are usually at the centers of galaxies. So the extreme gravitational fields and the relativistic jets, like the particles that move around the black hole's event horizon at nearly the speed of light,
Yeah.
these relativistic jets or the gravitational fields of the black holes could provide the necessary conditions to accelerate the cosmic rays to such high speeds.
Additionally, interactions within large-scale structures such as shockwaves from colliding galaxies might also contribute to the production of ultra-high energy cosmic rays.
So there's like a lot of possibilities on the table.
Yeah, when galaxies collide, they generate powerful shockwaves that can energize particles. Also, strong magnetic fields in these regions might also play a role in accelerating cosmic rays. All this talk of cosmic stuff actually reminds me of astrology and an astrologer listener slash friend of ours who also actually happened to suggest the idea for this episode.
Oh yeah. We like to call him the Edward Witten of our class. We'll feature him on our podcast sometime. Anyways, without digressing much, we'll get back to the point.
Yeah.
The intergalactic medium, which is composed of a diffuse plasma that's scattered throughout the space between galaxies, is another factor to consider. Because as cosmic rays travel through this medium, they interact with the plasma and its magnetic fields, and these interactions can influence the particles' energies and trajectories. So it can be lower, higher, whatever. But the main part we're focusing on is that it could allow them to maintain higher energies over long distances.
The discovery of the OMG particle led to the establishment of several major research initiatives aimed at understanding ultra high energy cosmic rays. One of the most significant facilities dedicated to this research is the Pierre Auger. That's Auger.
Auger.
Yeah. Uska observatory, and that is located in Argentina or Argentina.
Yup.
This observatory is one of the largest cosmic ray observatories in the world.
So the Pierre Auger
Yeah, Auger.
Observatory employs an extensive array of detectors spread over a vast area. It uses surface detectors to measure the secondary particles produced when cosmic rays interact with the Earth's atmosphere. They also use fluorescence telescopes to detect the light emitted during the interactions. Pratham, can you guess what we can do to gather as much information as we can about these cosmic rays?
Is it something to do with satellites?
Nope, not even close.
What about optimization and maths?
Maths AHL, I wish.
Maybe it's some kind of special telescope.
Ha, nice try, but no.
Okay, bhai, bata de. What is the secret?
It's all about combining data from both types of detectors.
Oh, that makes sense. By merging different perspectives, you get the full picture. Theory of knowledge kind of stuff.
Literally, TOK, yeah. So when we bring together the data from those different detectors, we get a complete understanding of these cosmic rays.
So it's basically like putting together pieces of a great cosmic puzzle.
Yeah, that's a Dadaji way to put it, but sure.
Please, okay.
Okay, so combining data from both the types is the key to gathering comprehensive information about cosmic rays.
Yeah, another important facility is the telescope array in Utah, which complements the Pierre Auger Observatory. This array uses a network of detectors and telescopes to capture data on high energy cosmic rays. The telescope array's observations help validate and extend the findings from the Pierre Auger. I'm messing this name up too much. Providing a more complete picture of cosmic ray behavior.
And observations from these very badly named facilities have revealed intriguing patterns in the distribution of the ultra high energy cosmic rays. So, for example, researchers have observed that these particles are not uniformly distributed across the sky. They actually seem to be clustered in certain regions because, that's expected, right? Because it's coming from one specific source or two specific clusters. So, that suggests there might be specific sources or structures that are influencing their paths.
And these findings have significant implications for our understanding of the universe. Studying ultra high energy cosmic rays can provide insights into the fundamental forces of nature, like you can say the structure of space-time and the behavior of matter under extreme conditions.
Like in the core of stars.
Yeah. And these particles serve as natural probes for studying relativistic effects and high energy interactions that are challenging to replicate in any common laboratory or something like that.
Yeah, you said relativistic effects.
Yeah.
Relativity, Rowland's observations and space-time diagrams, my favorite. But somewhere I feel like that Einstein was robbed of a thing after Neymar premiere, right? Because Lorentz got because he was a genius, he was only able to write the transformations without knowing how they work. But Einstein was a real genius who did all the heavy lifting and derived the equations using the postulates of special relativity.
On God, bro. Einstein on top.
Yep.
We'll be covering that in an episode again for sure.
Yep. So, similar to how relativity offers clues to the relationship between energy and mass, the OMG particle also offers clues about the early universe.
By studying these particles, scientists hope to gain a better understanding of the conditions that existed shortly after the Big Bang.
And this will help us piece together the history and evolution of the cosmos, shedding light on the processes that shaped our universe as we know it.
So much philosophy.
Yep, we'll do another episode on that also.
Of
like
course.
full philosophy.
Of course. The discovery of the OMG particle highlights the importance of scientific curiosity and exploration.
Big words.
Yeah. It is a reminder that even well-established theories can be challenged by new discoveries. The literally, like you can say, godly OMG particle
Yeah.
has not only expanded our knowledge but also shown us the paths needed for continued research and innovation, as something that a god particle would do.
Yeah, that's the same god that Newton fell for the planet explanation of the three-body problem, right? What's more, the broader implications for studying the ultra-high energy cosmic rays, they extend to various areas of fundamental physics. Like, understanding the mechanics behind the acceleration of these particles can lead to new insights on the nature of space-time and the fundamental forces that govern the universe. And it also has the potential to reveal new aspects of particle physics and cosmology, right?
Yeah. As we continue to explore these cosmic phenomena, we get closer to answering some of the most
Enigmatic questions.
enigmatic questions in science. The OMG particle has opened new avenues for research and has inspired hundreds of thousands of scientists to develop new models and theories to explain the mysteries of the universe.
We love hearing from our listeners and are always excited to dive into new topics.
You can reach out to us on quarktalkofficial@gmail.com at any time.